Hi everyone. I'll be doing this question. It's from past paper. It's from Mechanics 2, November 2023. It's from last year. So in this question, we need to find in part A, they say to show that the tension is 6/5 W, and for part B, they ask the magnitude of the force exerted on the rod by the hinge at A. Okay. So let's just draw a free body diagram first. That's your first step when doing questions like these. So this is our uniform rod AB. It doesn't have to be accurate, so just to get an idea, so you can label the forces. Because you get marks for the free body diagram too. 5A, 5A. This is 3A, and they say that a particle of weight 1/4W is attached to rod at B. Okay, so there's a weight of 1/4W at rod at B, and they say the uniform rod AB. So it's a uniform rod. So when they say uniform, so the total length of AB is 8A, right? So since it's uniform, so it's perfectly balanced. That means its center of mass is right in the center. So its center of mass is here, and you can mark this as W. This distance, this would be 4A from here to here. It's exactly in the center because they say it's uniform. And they say a light inelastic string of length 5, okay, attached to the rod at point C. Okay, so this is our string. So the tension is acting like this on the string. And for part B, they've given us that there's a magnitude of force exerted on the rod by the hinge at A. So you can say that there's a force this way. There's a force this way because you can call this reaction H because it's the horizontal, and reaction V because it's the vertical. That's for part B. So this is your diagram now. I'm telling you, you get marks for this too. They give marks for free body diagrams. So in case you make a mistake in part A and part B, the examiner will definitely give you marks for these. So for part A, they say show tension equals to 6/5 W. Okay, so to show tension equals 6/5 W, what we can do is we can take the moment about A, right? Because when we take it about A, the only forces we have to focus on is T, this weight, and this weight, right? The reaction forces at A, we don't have to consider them because we are taking the moment about A. So then you can write moment about A. And you should also know, so this length is 5A, this length is 5A, this length is 5A, right? So if all sides, so it's a triangle. It's a triangle with equal sides. So it's an equilateral triangle, right? So in an equilateral triangle, the angle is 60 on every side. 180 divided by 3. So we'll mark this angle as 60. Okay, now what we can do is, so we're about A, right? So we'll take the weight at B, 1/4 W into And it should be the perpendicular distance. You know, moment equals force into perpendicular distance. So either you could resolve the force or you could find the perpendicular distance. So what I'm going to do is, I'm just going to resolve the force because this angle is 60, right? So then this angle is also 60. So then you can write 1 over 4 W sine 60. I'm resolving it this way. I'm resolving it that way. So the distance I take is going to be perpendicular, right? See? Good. I'm resolving it this way. So 1 over 4 W sine 60 into 8A plus W, which is the weight of the rod, into, W sine 60 again, 60 into 4A, right? So these are anticlockwise. So you can take anticlockwise moments on one side and the clockwise moments on the other side. So these are all your anticlockwise moments. Then tension is in the clockwise direction, right? So you can put your equal sign and write tension on the other side. So you can resolve that too. You can write T sine 60. I'm resolving it this way. So it's perpendicular to the distance into 5A. Okay, now sine 60 cancels off. Now you end up with 2AW plus 4AW equals to 5AT. You can cancel off A. So you get 6W equals to 5T. Then T equals to 6 over 5W. So we got the first part. That's what they ask us to show. So for part B, they're asking us to find the magnitude of the force exerted on the rod by the hinge at A. So we have these two forces acting on A. So we can either take the moment about D, or we could also resolve the forces vertically and horizontally to find two equations. We could do that. So I'll do both ways. So you guys can choose whatever method you guys like and do the question. So let's do moments first. So let's take the moment about D. So about D it's RH into 5A about D. So the tension, we don't have to consider the tension because it's going right through the pivot, right? See, it's going right through the pivot. So there won't be any distance. We can't multiply it with any distance because it goes right through the pivot. So the only two forces we have to consider is 1 over 4W and W. So this is clockwise. Clockwise equals to anticlockwise. So you can write 1 over 4W into 8A sine 60. So 8A sine 60 is this distance. From here to here, the horizontal distance. As you know, moments, when finding moments, it should be perpendicular. The perpendicular distance. So you add this with W into 4A sine 60, the same way. So this will give you 5. You can cancel off the see they are common. So 5RH equals to 2, 1 over 4, 8 sine 60 is root 3 W plus this is 2 root 3 W. So RH equals to 3 root 3 over 5 W, right? You could do it like this, or what you could do is, I'll draw another small diagram, because the diagram above is it's confusing now, because there's too many labelings and stuff. So 1 over 4 W this way, this is rough, right? W, so we have RH this way, RV this way, tension this way, this is D, this is B, this is A, this is 60. You don't have to worry about the distances. So you can see, if you look along the horizontal, just look along the horizontal. So the forces acting along the horizontal is only RH and T resolved to the horizontal, right? We can resolve it to the horizontal. If this is 60, this angle is 30 because it's a equilateral triangle. So you've got equal sides. So the only horizontal forces that are there is T cos 30 and RH. Just those two. This goes the other way. RH goes to the left side, T goes to the right side. So you can write RH equals to T cos 30. So you write RH equals to T we found as 6 over 5 W cos 30. So we should get the exact same thing we found using moments. So 6 over 5 into cos 30. See? You get 3 root 3 over 5 W. This is way easier, right? So yeah, that's RH. Now to find RV, we don't have to find moments. We can do the exact same thing. Now you can see RV is along the vertical. Now look at all the forces going along the vertical. So what you can do is you can write 1 over 4 W going downwards along the vertical plus the weight along the vertical plus, no plus, sorry, this equals to RV, which is going upwards. The other two weights are going down, right? So these are upward forces now. RV plus T resolved vertically. So you can write plus T sine 30. See? So you get 1 over 4 plus 1 is 5 over 4. 5 over 4 W minus 6 over 5 sine 30 equals RV. So you get 5 over 4 minus 6 over 5 sine 30. This gives you 13 over 20 W. So RV equals 13 over 20 W. So in the question they say, find in terms of W the magnitude of the force exerted on the rod by the hinge at A. Exerted on the rod. So these forces are not on the rod. These two forces are the components of the force acting on the rod. So the force acting on the rod is this. R. That's the force acting on the rod. So to find this force, all you have to do is just find the Pythagoras theorem. RV is this way, RA is that way. So we can just write, I can write it like this. R RH, RV, and R. So it's a Pythagoras theorem. Question. So what you gotta do is So r squared equals rh squared plus r me squared, right? So r squared equals to 3 root 3 over 5 squared. I forgot the w squared plus 13 over 20 w squared. So r equals to square root. So you can just put these in your calculator. 3 root 3 over 5 over 5 squared plus 13 over 20 squared. So this gives you 601 over 400 w squared. So your final answer, r equals, so you get square root 601 over 20 w. That is your answer. I hope you all understood. If you guys have any doubts, just drop them in the comment section. So you can see this question is 9 marks, but it's pretty easy, right? You can get this done in 15 minutes. Yep, that's everything. If you guys have any doubts, just drop them in the comment section. And thank you so much. Have a great day.